this present 200 MTPA to 300 in coming 4-5 years. And the way things are happening, as I saw during my working days with Mekon, we are going to achieve it more or less by 2030. Another feature of India is our per capita consumption of steel still remains, in fact, less than half of the per capita consumption globally. We are consuming around 100 kg against global average of 217 point something kg per capita. So that shows that whatever capacity we are going to add, that is likely to get consumed. Because whatever happens across the globe also happens in any country which is developing. And National Steel Policy has also aimed to ensure that this consumption becomes 160 kg per capita by 2031. Now, from where this demand comes? So the largest demand contributor is building construction and other infrastructure, which we all are seeing everywhere. A lot of construction work is going on. Then automobile sector consumes around 9%, which is also witnessing growth year on year. Then capital goods and other equipments 15%, and remaining 11% is being consumed by other industries, including packaging, defense sector and all. Next, please. Next slide. So this is simply a slide talking about the growth which we are witnessing in terms of production and consumption. So we have crude steel production, which gets converted to finished steel products, which we are consuming in construction industry. And then consumption is also increasing on year basis. So this is just one glimpse in terms of million tons of steel, which is being produced and consumed. Next. Now let's come to straightway to the today's topic, where we are talking about mainly CO2 emission under greenhouse gas emissions. So if we talk about overall industry and this people who are responsible for greenhouse gas emissions, so industries are responsible for 34%, followed by 13% by transport. And then power generation and other things, they are the biggest emitter, and they are emitting around 41% of the total CO2 which is being emitted through different processes in the country. Out of this, steel, if we talk about this breakup of 34% of industries, steel is emitting around 8.5%, which is a very large, if we talk about one particular industry. So this becomes second to power. Power is mainly because of use of coal. Next. So if we talk about now steel sector, then in steel sector global average of CO2 emission is 2 ton of CO2 against per ton of steel produced. Indian average is around 2.65. So we are emitting 2.65 ton against 1 ton of finished steel produced. And this most of the steel is getting produced through blast furnaces. At least out of 170 odd tons, more than 100 ton is being produced through blast furnace route. And here you will be astonished to see the figure. It is 3.83, which has been put as on the higher side, but still it is very close to 3 if we see in today's scenario. And against all this, our target is to reduce all these emissions to around 1.6 tons per ton of steel produced. Then we say that yes, now we are into green steel production, where greenhouse gases emission has been substantially reduced. Next. So now we are entering into steel production part. So as I said, in blast furnace and basic oxygen furnace, these are the BF and BF full forms. So here we are contributing around 2.6 tons. And in the last slide, you must have seen 3.6. So that is the perception world is having about India. But India's data uh, is insisting that we are not exceeding 2.6 ton as on date per ton of uh, steel produced. If we talk about another technology, which is coal-based DRI is direct reduction of iron. Here it is more than 2.7. And since it is coal-based, so as you can see, it is very high. If this coal is replaced by natural gas, then we are just being able to make it half, which seems very promising. But problem is people are not going with natural gas because of cost, which I will discuss in subsequent slides. And scrap-based electric arc furnaces, because they are already using steel, which is already produced. So their emission is very low, 0.6 ton per ton of steel produced. So taking into account all these production processes, that is steel produced through scrap, steel produced through using natural gas, steel produced through coal, and blast furnace, our average comes to around 2.5, 2.6 ton of CO2 per ton of steel produced, which is very high. World average is only 2. Next. So as I already said, because of excessive use of coal in DRI or in blast furnaces, which is happening more in case of our country, this per ton emission is very high. So now, if somebody has read yesterday's newspaper, we have got one very alarming data. The average temperature increase in March worldwide is the temperature increase which has never happened in past in any of the years. It is 1.48 degrees centigrade. So it's very alarming. It may be because of war going on. A lot of carbon emission and heat is being generated because of this devastation of existing infrastructure, use of explosives and all. So it may be an abrasive figure, but then whatever is being witnessed year on year basis, there is a need that we should decarbonize as early as possible. Maybe in next 5 to 10 years, we should be doing it in a drastic manner so that certain things can be reversed. And as people say, we are the last generation which can do something in arresting this phenomenon. After that, we'll only be adjusting ourselves to the damage which has already happened to the environment. So green steel is a necessity. Green steel is basically a steel produced in such a manner so that carbon dioxide footprint is very low. Next, please. So what we are defining in India is any steel which is produced emitting less than or equal to 2.2 ton of CO2 per ton of finished steel will be considered as green steel. There is no standard available globally to say, yes, this is the definition of green steel. So what ministry has come out, Ministry of Steel in India, it is 2.2 tons. But this will definitely be getting reduced year on year, because by 2070, we have to become net neutral. That is, there should not be any production of steel which is emitting CO2. And in order to encourage and to make people aware, government has also come out with the star ratings as we are seeing in electrical and electronic products also. So 3-star rating is the one where production of 1 ton of steel is emitting CO2 between 2 to 2.2 tons. Similarly, 4-star is between 1.6 to 2 tons of CO2 emitting through production of 1 ton of steel, and 5-star will be 1.6. Now, what government is further doing, which has not happened, but it is in the process, government is going to mandate that in any of the projects being executed by PSU or Government of India, there will be a requirement of at least 20% of steel to be used as green steel. There also they are putting certain percentage. For example, my figures are only example. 5-star should be 5% minimum, 4-star should be 10%, and 3-star should be say 6.5 or something percent. So this will happen. In fact, there were talks to get it immediately, but since in India the rating process has not matured enough. I mean, who will tell that this particular steel has been produced at 5-star category? Since this type of infrastructure is not there, so government has deferred it. Maybe it will start from 2027. Because this is also a time when European countries will also be introducing their CBAM, Carbon Border Mechanism. So that will also start, where all those steels which are being produced below certain ton of carbon dioxide emission, those will be charged additional tax as high as 28%. And India is the second largest exporter of steel to European Unions. So when this gets implemented and if we are not ready with the reduction in carbon emission, there will be problem. Our exports will get hit because 28% tax is a high figure, and others like Korea, those who are really doing a very good job, there is already less than 1.5 ton emission per ton of steel. So they will take additional advantage and make our country may suffer. So need of R is to switch to green steel production as early as possible and also develop adequate infrastructure. I think here we start for a minute so that we can just take a feedback. Are we all in same platform understanding things? Or there are some queries, there are some confusions, or topic is not, giving lot of encouragement?
No, no, sir, it is clear. It's very interesting topic, sir.
Okay, because what I meant by taking this steel sector was similar things are to be introduced in other industries also,
Yes, yes.
including construction, because construction sector is also one of the largest emitter of greenhouse gases. So the concepts which we will be following here will be the concept which can be followed
emit
anywhere else.
1 ton of CO2.
Pardon?
1 ton of cement production emits 1 ton of CO2. Like in steel, 1 ton of steel produces 2.2 or more CO2. Like in cement, we are getting 1.0 or 0.9 or like that. CO2.
That's true. And we are only talking about steel and cement. But if you go for steel
Electricity.
product, no. Electricity remains the problem because it has to be coal-based until we switch over to other like nuclear.
Exactly.
Because solar and those things are having certain limitations. They can produce, but then there's a limitation. Say, for example, solar, it can produce only during daytime. Wind, dependent on wind speed. So here, what we can do is we can produce, but coal or nuclear, they will remain at the core because they will be supporting the overall production. So we may not be able to get rid of coal produced power for another 20, 30 years to come. Yes, of course, they are doing their own to reduce emission by introducing new technologies, but this problem will remain. In case of copper, in case of aluminum also it is very high. It is 3.5 to 4 ton of CO2 produced per ton of those metals. So everywhere capacities are getting increased. So volume of CO2 emission will also keep increasing, even if we are reducing per ton emission due to technological interventions. For example, suppose even today we start producing steel at 1.6 ton, and we also talk about capacity to go from 200 to 300. So even if we multiply this 1.6 with 300 million ton, we will be having same amount of CO2 being emitted as we are doing today. So this is another aspect. When we are increasing capacity, when we are producing more and more, even with intervention of resulting into reduction in emission, net total remains same or more. So this is another paradox which is to be taken care of.
Sir, shipbuilding steel, is India producing shipbuilding steel?
Well, there are many type of steels which were not being produced in India. Like if you talk about many grade of steel for automobile sector, many steel which are used in electric component production. So these are being now introduced through PLI. Government has already rolled out PLI 1, PLI 2 and PLI 3, where production linked incentives are being given to produce different kind of steels, which also includes steel for shipbuilding. Otherwise, it was not happening. So this will happen, say, their targets are 2027-28, when production will start. So for shipbuilding also, we will be having our own steel produced, as we will be having for automobile as well as for electric steel. And there are some more varieties which are used for defense sector and nuclear sector also. Those special steels are also now being produced through PLI scheme, which government of India has introduced for steel sector, giving huge amount of incentive. It is 4,000 crore plus incentive given against production. Next, please. So what I will expect is you people keep saying something in between so that there is a discussion also. And it gives me some rest also in between. Okay, so we have already discussed why to green steel. So all those issues which are hurting our climate, resulting into a lot of weather pattern changes, resulting into crop damages, unseasonal rains, floods worldwide. So this becomes a core of the problem, which needs to be addressed by switching over to green steel. Other than that, there will be certain incentives which will be coming out of competition. As I told you, there is introduction of CBAM by European countries. So if you want to export your product, you have to become greener. So these type of incentives are also there. Then certain companies are also now looking for green steel in making their own, say, consumer goods. So they will say, I will use your steel only if it is producing less than 2 ton of CO2, for example. Similarly, there will be some funds which will be given to you only if you are using green steel. They are ESG funding, and worldwide now this is happening, green in name of green investing. So there are many things which will come as incentive. There will be many things which will come as deterrent. So ultimately, industry is to align in such a manner so that our per ton emission of carbon dioxide keeps on reducing on year basis. Because it is not end of the world. Okay, after 1.6, it will not be reduced. After another 5 years, 10 years, it will be made 1.2. Because ultimately, we have to go to net zero. Next, please.
Mr. Saab, if you permit,
Sir,
can I
good
say
morning.
good
sir.
morning, good morning. I've been listening to you very patiently,
Sir,
and since you made an appeal to our friends here that they should be asking question or comment which can give you a little bit of rest. So I
sir.
thought I'll give you about 2 minutes rest.
Thank you, sir. Thank you. Thank you.
All right.
बताइए.
Very good morning to all the friends who are here, all the professional engineers. It's so good to be amongst you. Now, what Mr. Dikshit was explaining to you, I was just thinking of supplementing something. A day before yesterday, we had organized a, an award function where Mr. Gadkari himself was present and he was giving out the awards. At the same time, there are a number of schemes that we have launched. And keeping in view the kind of work that is going to be done for the reconstruction of Middle East, whether we like it or not, we will have to go for green steel. And therefore, a scheme of green rating of steel on the basis of CBAM provisions that has also been announced day before yesterday. I
That's
would
great.
I would like each one of you, those who are there, to join this particular team and to basically understand how do we conduct the audit and how are we going to be rating the steel as green steel. The parameters are all known, but then we in CIDC and Engineering Council of India, we just don't do things just simply collecting the papers. We physically go. So just let me know that who are our professional engineers who may like to become auditors. Auditors for green steel rating on the basis of CBAM provisions. Of course, there is a Ministry of Steel provision which also exists, but the fact of the matter is that probably Ministry of Steel parameters are not as ambitious as what CBAM is asking for. So that is what I thought I'll let you know. Please send you can send the email to Mr. Yograj Singh or to Mr. Dikshit if you like, because he is going to be, uh, preparing a strong cadre of auditors. That is what I had to say. Dikshit sir, now I think you have had enough rest. You please go.
Thank you, sir. Thank you. And it is good. In fact, I was also planning to talk about this particular thing, that whosoever are interested, they should start reading literature, going deeper into the subject, so that future audit teams can be developed out of professional engineers. And as I told you, this scheme of 5-star, 4-star, 3-star rating has not been implemented by government only because of this chaos. Who will decide that my product is 5-star, 4-star, 3-star, or no star? So that framework is still under discussion. And once it is finalized, only then these things will be rolled out. And this will also be benefiting construction industry in terms of ratings, because when we are using steel with the lesser emission, our ratings will also go up when we are talking about green rating of buildings and all. So it is going to be a win-win situation. So earlier it happens is good for everybody. Now, why and how these things are being happening in Paris Agreement, Government of India has also made some commitments. So one is in terms of reduction in emission. Another is reduction in fossil fuel consumption and increasing non-fossil fuel based power generation. And then carbon sink. So if we talk about target in reduction in emission, first target was to reduce in 15 years around 30 to 35% of what we were in the year 2007. From that, or 2002, I'm just forgetting. So that benchmark is to be fixed, and after that we have to keep reducing year-on-year basis, for which these NDCs have been committed by Government of India. NDC is nothing but nationally determined contributors, which are committed by particular country itself, that this is what we are going to contribute. So now next time will be when will be by 2030 we'll be reducing it to 45%, and then by 2035 it has to be 47% against the benchmark of 2005 levels, not 2007, not 2002. It is against 2005 levels. So as on date, we have achieved first phase, first target has been achieved by us. In fact, we have crossed it slightly. Second, we are putting our efforts, and it is likely that we will be able to take care of this also. Because whatever capacity is being added in steel, uh, those are with latest technologies where emission is quite low. So since it is actually happening, so we can say for sure that we will be able to achieve the target of 45% reduction by year 2030. And the steel sector will definitely contribute. In renewables, everybody knows that we already exceeded what we were to achieve by 2030. Currently, we have 52% plus against the target of 2030 of 50%. So here we have done a very good job as country. In terms of additional carbon sink, it is happening, but because we don't have those technologies in CCUS, where we can drastically go for reduction, it is not happening with that pace. But on the same time, we are very close to the target which was given, committed by Government of India during Paris Agreement. Next, please. Now, this is our journey. When I talked about 2005 as base year, steel industry was emitting 3 ton plus carbon dioxide per ton of crude steel produced. By 2020, it has become 2.64. 2030 aims to make it 2.2. And by 2070, it is to become carbon neutral. When we say carbon neutral, it means there should be elimination of coal altogether for steel making process. These are the commitments which have been given by Ministry of Steel, and it has become part of those NDCs which we discussed in earlier slide. Next. This is when we talk about green steel, how green steel will be made. So in steel making process, basically there's a reduction of iron ore which is to be happening. Today we are using coal, natural gas for doing it. That is reducing process for steel making. Now we can replace it by hydrogen. So for making hydrogen, which should also be green, we need to have electricity which is to be generated through renewable sources. So the cycle will be like you produce renewable energy to the extent the quantity is needed, put it to electrolyzers for making green hydrogen. This green hydrogen will be used in blast furnace, DRI, and all those steel making processes where green hydrogen will be acting as a reducing agent. And similarly, electric arc furnaces, which is using scrap. Scrap is being put in arc furnace. There also a lot of power is consumed. That should also be replaced by renewable. So when we are able to achieve this slowly in year-on-year basis, maybe 5%, 10%, 15%, 20%, and so on, a time will come, which is 2070, when our steel will be having zero footprint of carbon emission. 5 years back, it was looking something impossible. But the kind of efforts which are being made, the kind of successes we are witnessing through pilot projects worldwide, it is very encouraging, and it appears that we will definitely be able to make these dreams come true. Next, please. And go to back last slide. One slide I think we have skipped. It is just nothing more than what I've already discussed. So basically what we have to do is we have to use that type of energy which is low carbon. So it is renewable energy. Through renewable, we have to generate hydrogen and other energies which can be introduced where carbon emission is low. We also need to improve material efficiency. which I say I'll just give one example. Today, India is using iron ore, which is having, say, iron content of 60%, Fe60. If we increase it by 2%, say, Fe content is 62% per ton, then our carbon emission reduces. So this 60% to 65%, if we can bring, there will be substantial reduction in carbon emission per ton of steel making. So this is achieved through beneficiation. So iron ore is to be beneficiated so that Fe content increases. So this is another way, that is by increasing material efficiency, we can reduce carbon emission. Then electrification wherever possible, and whatever power we are consuming in steel making or in cement or in any type of production, that should be slowly replaced by renewable power. So a lot of capacities are being generated, and industries are to switch over to green power, so that coal-based power consumption reduces and things become greener. So this is now applicable for everybody, even for construction industry. अभी हमारे डीजी साहब ने जैसे बताया, डॉक्टर स्वरूप ने, गडकरी साहब का इनॉग्रेशन में उन्होंने ये बात बोली थी कि इवन फॉर माइनिंग, कंस्ट्रक्शन एंड ऑल इंडस्ट्रीज, डीजल को हटा करके आइदर वी शुड गो विद सीएनजी, एलएनजी, or even we should try to use these equipments through power by providing power. That is, if suppose our coke lane is working using electricity, so all the diesel consumption goes out. In construction of road, highway, it seems to be something difficult, but when we talk about mining, where all mining activities are happening within, say, 5 kilometer, 10 kilometer, so all these equipments which are being used for mining can be switched over to power. Companies like MOIL, Manganese Ore India Limited, they have already started working on it because their equipment are slightly smaller. So what they are doing is they are getting rid of diesel and giving electricity to all these equipments for their mining purposes. So this will be reducing consumption of diesel in a very big way. So these type of ideas are to be implemented across industries. Then, of course, we have carbon capture utilization, and carbon capture utilization and storage, where we talk about making ethanol, methanol, and other products by capturing carbon. Again, pilot projects are also happening. Commercial projects are also happening in this field, but pace is slower because of cost component. Because this is definitely an additional cost. So until unless it is incentivized by government or industry, this process will not become faster. So we need policies, we need some penalties also, some incentive schemes, easy finance for these things, and over and above skilled workforce. We need people who can handle hydrogen. We need people who can contribute in carbon capture and those technologies. Because hydrogen, as I said, seems to be easy S2, but it's explosive in nature. So a lot of precautions are to be taken care of. Then it is a very small molecule. It is only S2. So it is having only 2 atoms. So in per cubic meter, there is very small quantity of hydrogen in kg. So density is very low. So in order to generate and store and to use hydrogen, you need to pressurize it at a very high pressure. Only then you have substantial hydrogen available in kg or in tons. So for that you need compressors and all. So a lot of safety, work culture change, those things will also be required, which need skilled manpower. Who will train them? That becomes a big question also. So these are the things which are to be done across industries. Steel sector is one of the examples which I have taken today. Next. Now these coming slides will be nothing more than what we have already discussed through interaction. So I will just go through these things faster. So estimate by Government of India is that by 2030, because of policy interventions and some incentives, there is likely that around 4.5 MTPA green steel will start getting produced. As I have been told, around 25 to 30 small scale steel producers are there who have been given carbon rating also, 3-star, 4-star. So things have started happening. So in next 4 to 5 years, it is expected that around 4.5 MTPA will be green. So government policies, introduction of those ratings, automobile companies, they are also insisting that we will be using green steel to become net zero on their own by 2030-40. CBAM, which has already come, now it will be implemented next year. So all these things will be giving a lot of incentive to green steel producers. Next. But there are challenges also, as I told you. We don't have proven technologies to use, say, hydrogen or to reduce use of coal in blast furnaces. So hydrogen can only be introduced in certain percentage. And that certain percentage will reduce consumption of coal and coke to certain percentage only. So blast furnace route will never become green. It is because of technological challenges. The very nature of blast furnace way of producing steel. Then certain pilot projects are also on. There are one project which has been taken by SAIL, Steel Authority, where they will be experimenting introducing hydrogen in their blast furnace. So they are planning to go up to 15% hydrogen consumption in gradual manner because it is a pilot project only. And they will see how they are able to reduce carbon emission and reduction of coal consumption. Another challenge is in green steel production, there is no regulations. There is nobody who is saying this 2.6 per ton steel CO2 emission is not allowed. If you do that, there will be a penalty. So those type of regulations are also not there. So things are happening in tits and bit manner so that it is not giving that effect and things are not happening the way they should have happened. So accordingly, demand is also not there. Markets, they are also going for wait and watch. And then, as I already told, we need skilled manpower. Not only workers, we also need engineers who can design, who can scale up a pilot project into large commercial scales. Because pilot project will be producing, say, 50 ton of steel per day. And here we are talking about million ton of steel produced per day. So that pilot project, whatever we learn, it has to be made bigger and commercialized. So we don't have those kind of engineers who can do it. In fact, because it has never happened in past, so we don't have. But as things happen, there will be progress. Next. Again, same kind of things. And for making 1 million ton per annum green steel plant, which is 100% green, we will be needing green hydrogen, for which there will be an investment of around 2.5 to $3 billion. There will be use of renewable power that will need around $2 billion US for producing required quantum of renewable power. And then making all those capital goods, land costs and all, that is another 2 to 4 billion US. So this total investment is quite high, crossing $10 billion to produce 1 metric ton per annum of green steel. So things are costly. So it will happen only gradually. People will be improving their efficiencies in different processes to reduce carbon emission, and slowly they will be meeting those targets which I showed you earlier. Next. And then in India, unlike other countries, we are having shortage of scrap. If we recycle, that is, if we go with the circular economy where things are produced and when they become of less use or no use, they are again put into circular economy. When that thing happens, then your carbon footprint automatically reduces. Suppose, I'll give you example. We are having lakhs of vehicles which have crossed their age of 15 year and 10 year as per regulation of Government of India, that beyond that these vehicles will not run. But these vehicles are not getting scrapped and reaching scrap yards, because in certain states they are allowing 15 years to 20 years also. They give some fitness certificate and they are allowed. So all those vehicles which could have been scrapped, generating lakhs of tons of scrap, which could have gone to industry, is not happening. So when that starts happening, when India starts literally following these regulations and scrap policy is finalized with incentives, then this process will also increase. And because percentage of scrap-based steel will increase, so this will also help in reducing average of carbon emission significantly. So we are just waiting. Policies are already there, but then because I was also involved in one of those committees. So I find state governments are not able to, or they are not willing to cooperate to the extent they should have. If they make their rules strict, then a lot of scrap will be generated and things will improve. Hydrogen prices also remain challenged. Until it becomes, say, less than $1 per kg, it will not be viable for producing steel at competitive rates. So this is one challenge. Then other things I've already talked. Today we are producing hydrogen, green hydrogen at around between $4 to $5 per kg. So this $4 to $5 per kg is to come down to below $1 per kg. Only then it becomes viable for use in steel sector. But things are happening. 4 years back it was $7. In 3 years it has come down to something between 4 to 5. So a day will come when we have our own production of electrolyzers and other infrastructure, and we'll very soon see that these prices are very close, not $1, but very close to $1. Next. This is just what I have already talked about, how we can make green hydrogen using electrolyzers, where water is broken into its two components of hydrogen and oxygen, and hydrogen is used. Next. So green steel is relatively expensive because the processes which are involved will consume hydrogen, which is costly, will consume renewables, which are today quite economical, but still costly, because it is not only using it, it is also to replace your equipments to make them fit to use these renewable things. Next. Then regulations have started coming up. As I told, European Union has already introduced. There are certain things which should be done. Like if I am able to reduce carbon footprint by certain things, I should be having a very good, developed, matured market for carbon trading. If I am able to. Similarly, if I am producing steel, which is emitting more carbon, then I should be able to have carbon credits purchased so that I can follow those regulations. So my selling carbon credits and my purchasing carbon credits should happen now, because industry is talking about it for so many years. In other countries, it has started happening. In India, it is still not matured. It's in fact in a very infant stage. We are only talking about it. Next. This is what I talked about carbon market. So here we need to work faster so that those who are becoming efficient, they are also awarded. Awarded by the way, they are able to sell their credit points and get some money. Similarly, I am able to make the compliance by purchasing those points. So it will become incentive to both less carbon emitter and those who are somehow not able to do it faster. But they will pay a price. So this will become a very big incentive for people to go greener in all kind of industries, not only steel. Steel may take time, but in other industries, if we just switch over to renewable energy, my process, suppose it is using 10 megawatt, and I'm able to replace everything, say 10 megawatt through green, then my product becomes greener. And whatever carbon I am saving, I get money also. So those type of things should happen. I visited during Vishwakarma Award evaluation, I visited some companies, they are doing it. They are replacing diesel and furnace oil through natural gas and through renewable energy in a big way. But their product becomes a bit costlier and there is no mechanism in place to compensate their efforts. So this should happen faster. Bureau of Energy Efficiency is the agency to take care of this carbon credit market. Next. I think we are very close to thank you slide. Next. This is for steel sector. I'll just go too fast. There is a process called sintering where iron ore in fine form along with the other material, lime and all, they are blended, make a sinter, small pieces, and then put in blast furnace. So in the process, heating is done at more than 1000 degrees centigrade. So whatever heat is getting generated, that can be used. Technologies are available. In one or two plants only it is there in India. But if it can be used, each plant can generate on its own some 20 megawatt of power, doing nothing, just by capturing this sinter waste heat recovery. Similarly, in coke making, technologies are available where you can reduce carbon footprint. This coke dry quenching, whatever exhaust comes, that is also used as power generating fuel. Then iron making, many things are there. Blast furnace, we can put top recovery turbine. So around all these things which I am talking about, these are implemented. These itself are capable of producing 60 megawatt of power without using any additional fuel and significant reduction in carbon emission. Because 60 megawatt of power generation itself will mitigate so much of coal consumption. So these technologies are available, being used, and things are happening fast. In other industries, maybe we can use those energy efficient motors, IE4. We can go to IE4 in standards. We should use VFDs wherever possible. So these type of things can be done by any industry where power consumption is reduced and power is also replaced by green. Next. It is about natural gas. It is also not being used because of cost. The industry needs it at $6. It is available at $10. And then uncertainty, which everybody now knows. We are somehow able to meet the need of natural gas for CNG, that is for vehicles, and for households, pipe natural gas. Because 80% or 60% of that comes through imports. And because of this war, there's a problem. So this is another deterrent because our industry will be dependent on imported natural gas. It is costly, and that uncertainty also becomes a negative factor for people to adopt natural gas. Next. But natural gas consumption makes carbon emission half. So it's a big advantage. And then renewable energy, it is to increase, in fact, it has to become double by 2030-31. It will become 184 TWH. As on now, penetration of renewable is only 7.2%. It is to become at least 50% by 2030. Aim is 43%, but then with kind of availability, it should become 50% by 2030. So this will play a very big role in reducing carbon emission. Next. Then material efficiency, I have already talked about it. That if we increase carbon content in iron ore through beneficiation, we are having a clear-cut advantage in more capacity utilization and in reduction in carbon emission. Next. Then green hydrogen, I've already talked about. It says that it should come down to around $0.88 per kg. Then it will become at par with what price industry is paying for coking coal. Pilot projects are going on, as I told, and in 6 months from today, results will start coming out. Next. Natural gas I already talked about, $6 to $8. If it is available, then only it becomes feasible for them. And in today's market, it is more than $10 per MMBTU. Next. This is the roadmap we have already talked about. If we take 2024 as base year, by 2070, we have to become carbon neutral. So our journey will be through energy efficiency, use of renewable energy, maximum use of pellets in case of the steel industry, then increase use of scrap, introduction of green hydrogen, biochar, then CCUS, that is carbon capture utilization and storage, and some other disruptive technologies which may come in future which have not been visible today. Next. And this will be the journey in a specific energy consumption terms. We'll be reducing it to 4 from today's 7.1 gigacalorie per ton of steel. I think this would be the last slide. Thank you. I hope I've been able to do justice with the subject, and I also tried to make it relevant with respect to other industries also. So in 5 minutes, maybe we can have, Yuvraj, how much time you give for question answer session? Oh, it is open.
15 to 20 minutes, sir.
Okay. So questions are welcome. We can discuss. Actually, last month,
in
sure.
European Union, in the shipping, already European Union emission trading system already started from
Yes,
2024.
सर प्लीज आपका कैमरा ऑन कीजिए.
हाँ.
Thank you, sir.
European Union shipping industry already carbon trading is going on. That I am telling. Already from 2020.
China, USA, European countries, South Korea. they are having now reasonably developed carbon trading mechanism.
Yes, sir. Yes, sir. Correct. And then in future also IMO, International Maritime Organization, by regulation, it will be implemented in all the countries.
Yes.
They are also planning. Thank you,
True.
sir. Thank you, sir. It must come by regulation, otherwise.
Yes, it has to come through regulation only. In India, Bureau of Energy Efficiency responsible nodal agency for doing it. They are working on it. There have been presentations, there have been workshops where things are being discussed. But unfortunately, it is not visible on ground.
Yes, it will take time, maybe.
It will take time.
That's.
Sir,
Thank
one
you,
of
sir.
my
Thank you, sir.
question.
Actually, for conversion of that is from artificial process to natural process, that is, we are thinking about this carbon decarbonization. So for that, whether there is any easiest way so that we can eradicate decarbonization in coming years. So what are the easiest way that is which will be very cost effective and human attitude will be the forefront like this to
There are two easiest way which can be done even by us as individual. One is use of renewable energy, another is generating carbon sink. When I say carbon sink, it is plantation. We
Yes,
can
sir.
plant trees.
Yes, sir.
We can give our rooftops
Yes, sir.
for solar production.
Solar power.
I told you, I will tell you, in Delhi, there are 2,700 producers of solar power through their rooftops. 2,700 only. But capacity is very high. They are producing something like 20, 30 megawatt. Because bigger schools, school buildings, and those have also been converted. There's metro also having stations where they are putting rooftop solar. Myself, in 2017, put a 3 kilowatt solar power system. So that time I was one of the 50 people in Delhi, a city having a population of 3 crore, who had this solar power installed. So I was one of them. Even today, I am one of those 2,700. So the thing is, people are not doing their part of the work. We are talking pollution kam ho jaye, sab theek ho jaye. But we are not doing enough for becoming greener on ourselves. Just imagine, 140 crore people, 140 crore people, if their own effort, if they can reduce 1 kg of carbon dioxide emission per day. So we are talking about 140 crore kg of carbon dioxide emission reduction per day by India by doing nothing, just by becoming aware.
Yes.
I very recently come from Ranchi. Ranchi is a very green place where I was working, Mekong Limited, some big colony, 125 acre of land. You know, it's green. So, patte girenge, what they do, they gather them at one place and उसको आग लगा देता है. ये मतलब पढ़े लिखे लोगों का मैं बता रहा हूँ. दिल्ली में something which is fined by 5,000, 10,000 rupees, they are doing very casually. So everybody, I'm telling you, everybody is responsible and being irresponsible in this process.
Yes, sir. Actually, government and NGOs all and the general public should have the awareness regarding this eco-friendly aspect in a larger quantity, so
Very
that
correct.
we can protect our environment by hook or by crook.
देखो क्या है कि if I'm not wrong, I'm Mr. Tapas, I'm interacting with right now.
Yes, sir.
तो देखिए तापस साहब क्या है, जैसे ये हमारा ECI है. We are having people We are having people like-minded to the extent that we all want to learn and teach. We want to upgrade ourselves. अगर इसी तरीके के ग्रुप्स कुछ इस तरह के अपने कुछ डिसीजन लें कि भाई ठीक है, इन माय कंपनी, इन एट माय होम, at my workplace, wherever, I will start doing something in this direction. Just see the effort.
Yes.
And that is the
Thank you.
beauty of having associations
Yes.
and these type of things, where we can
Yes.
provide a forum where ideas can be exchanged, and
Right.
some people at least take lessons and implement.
Right. Thank you,
और
sir.
कोई? Thank you, तापस जी. और कोई?
Thank.
Sir,
सर
I
मेरा
myself, Monia Ghoshal,
हाँ, घोषाल साहब बोलिए.
I have experience in steel industry, Mekon, Tata Jamshedpur, and Essar Steel. All these things I have done civil works, not the steel works. In Mekon, I have done surveying and conditioning of the steel plantations.
So when you were at steel plant, the kind of pollution which you have witnessed,
Yeah.
PM 2.5, PM 10, anything and everything was there.
Yeah, sir. Now, sir, I
And
have
you must
registered
have
value.
seen,
I give a registered value.
कि 50% चीजें केवल इसलिए खराब हैं because
Yes,
people are not doing their part of job.
Yes, sir. So, sir, I want that, Jograj sir's email ID and your email ID. I will that, I have a registered value. So, I want that, green rating part, what that Dr. Swarup was telling. So, could you please provide your mail ID? Then I will mail my biodata so that something can be done.
हाँ, sure. योगराज जी आप ले लीजिएगा. जो इनवाइट है उसमें
आई
योगराज
विल,
जी का ऑलरेडी आईडी है.
अच्छा.
उसमें
मैं
I
आपको
will do
भेज
it.
दूंगा सर.
Yes, sir. Thank you, sir. Thank you.
और कोई?
Sir, whether we will get any certificate for participation this program?
यस सर.
Okay, sir.
एक्चुअली
Thank you.
योगराज आप थोड़ा सा एक्सप्लेन करो ना. आप लोग
सर,
क्या
सर,
करते हो इसमें?
इसमें सभी को
पॉइंट
हम
जनरेट होते हैं, क्या क्या बताइए थोड़ा आप.
ये एवरी वीक जो हमारा सीपीडी प्रोग्राम हो रहा है, इसके लिए हम सर्टिफिकेट सभी को इशू करते हैं, और पिछले 2-3 इवेंट के सर्टिफिकेट अभी नहीं हो पाए हैं क्योंकि दूसरे इवेंट की वजह से हमें थोड़ा सा टाइम की प्रॉब्लम की वजह से नहीं कर पाए थे.
And is
ये
there any
सर्टिफिकेट,
opportunity for me to be a member of this STEM institution?
सॉरी,
Is there any
डेफिनेटली. अभी
So,
इनका ईसीआई का एक फॉर्म है, आप उसको फिलअप कर लीजिएगा.
अच्छा.
आप बिकम अ मेंबर एंड बिकम अ कंट्रीब्यूटर आल्सो.
Okay.
और आप हमको आइडिया
Okay.
दीजिए क्या करना है, कैसे करना है, और
And,
पार्टिसिपेट भी करिए इसमें.
and I think such types of programs is very beneficial for all of us
डेफिनेटली.
for expansion of our knowledge and attitude in the coming
और
years.
दूसरा युवराज, हम एक काम और भी कर सकते हैं. देयर से
सर.
आई चूज माय टॉपिक एंड गिव अ लेक्चर. यू कैन आल्सो कलेक्ट टॉपिक्स जो लोग जानना चाहते हैं कि इन टॉपिक पे भी कुछ हमारे डिस्कशंस हो, प्रेजेंटेशंस हो, तो भी आप कलेक्ट करो सो दैट वी बिकम मोर रिलेवेंट.
सर,
Yes.
जो भी इंटरेस्टेड हैं वो मुझे मेल कर सकते हैं, और मैं डिस्कस करने के बाद उसे इम्प्लीमेंट करूंगा कि आपको वो आपका स्लॉट अलॉट कर दिया जाएगा सर. जो भी इंटरेस्टेड हैं आपके, आप लेक्चर देने के लिए जिस सब्जेक्ट पर भी, मेरा सभी से अनुरोध है सर.
आपकी आवाज साफ नहीं आ रही है. आवाज आपकी बहुत साफ नहीं आई. हाँ,
आपकी
बताइए.
आवाज कट रही है.
आप एक काम करिए, उसको थोड़ा इसमें मैसेज में डाल दीजिए व्हाट यू आर ट्राइंग टू से. आपकी आवाज नहीं आ रही है. आपके एक्चुअली मुझे लग रहा है कि 2 जगह सिस्टम में आपका ये
नहीं
ऑन
सर,
है, इसलिए
एक्चुअली
आवाज
उनको
इको कर रही है।
इंटरनल होम घर की आवाजें आ रही है, वो पर्सनल
हाँ
बातें हो रही
कुछ है, हाँ कुछ हो रहा है। तो चलिए, अभी अगर कोई और टॉपिक नहीं, हमारा कोई क्वेश्चन नहीं है, देन वी कैन कॉल इट अ डे। इट वाज वेरी मतलब बहुत अच्छा लगा आप लोगों से बात करके। और ये मेरा मतलब दिस इज द फर्स्ट टाइम आई हैव इंटरेक्टेड थ्रू ECI प्लेटफॉर्म। I have told a few of my senior colleagues who have done well in their career to share more topics. So we can talk about integrity management. We can talk about contractual things, contracts management. We can talk about project management and many other topics uh, in coming on coming Sundays. आप लोग भी थोड़ा अपना फीडबैक दीजिएगा, अगर कोई पर्टिकुलर टॉपिक ऑफ इंटरेस्ट है आपका, योगराज जी को दीजिएगा, तो योगराज जी फिर इसमें राइट काइंड ऑफ पर्सन को ला करके सेशन करा देंगे। तो कंक्लूड करो योगराज फिर आप।
Thank you, sir.
ओके सर, थैंक यू सर।
Sir, thank you very much.
चलिए, ओके बाय।
थैंक यू सर, सभी को धन्यवाद। मिलते हैं अगले इतवार, अगले रविवार को मुलाकात होगी सर। धन्यवाद।
Okay, sir. Thank you.
थैंक यू वेरी मच।